specific than that you'll be watching out for next in its trajectory?
Well, if they try to communicate with us, some kind of Morse code, some kind of language that we would understand, some mathematical language, for example, that would clinch it. Rather than getting static on a radio, getting an alien civilization share their knowledge with us, that would nail it to the wall.
Quantum AI has finally analyzed 3I/Atlas, and what it reveals is unlike anything we've ever seen. According to its calculations, this object isn't behaving like a typical comet or asteroid. Its trajectory, rotation, and material composition suggest something far more complex, something that challenges the limits of conventional physics. The AI shows that 3I/Atlas isn't random. Its path through the solar system is precise, almost as if it's following a preordained route. Most interstellar objects follow chaotic, unpredictable trajectories influenced by gravity, radiation, and collisions with dust and micrometeorites. But 3I/Atlas seems to have a level of control over its motion that defies these natural forces. Even when accounting for solar radiation and gravitational interactions, its movement remains too perfect, according to the AI. Tell us in the comments, does this sound like natural physics to you? We're genuinely curious which team you're on. Then, there's the matter of its structure. Observations combined with quantum AI modeling suggest the object is irregularly shaped, elongated, and unevenly dense. Unlike normal celestial bodies that spin or tumble randomly, 3I/Atlas rotates in a highly unusual manner. Sometimes it appears almost inert, while at other times it releases tiny jets of gas or dust in unpredictable bursts. These outgassing events don't match any known cometary patterns. They're inconsistent, sporadic, and extremely precise in timing, according to the AI's simulations. Perhaps the most alarming insight is the object's origin. Spectral analysis indicates that 3I/Atlas is composed of materials rarely found in our solar system. Ices formed in extreme interstellar conditions, exotic dust, and complex carbon compounds suggest it spent millions of years traveling between stars. Before we go deeper, make sure to subscribe if you want to follow this investigation in real time, because the next part of the story is where everything gets even stranger. And trust me, you don't want to miss what quantum AI found next. It's a true interstellar traveler, but not just a frozen rock. It carries the fingerprints of processes that are still mysterious, even to modern science. Quantum AI raises an even more unsettling possibility, that 3I/Atlas might not be entirely natural. Its motion and composition are consistent with patterns that could indicate intelligent design or guidance, though nothing confirms this definitively. While scientists remain cautious, the AI shows that the combination of precision, trajectory, and material composition is so unusual that it demands serious attention. Finally, the AI warns of subtle consequences. 3I/Atlas's path, though not directly threatening to Earth, could produce gravitational or magnetic disturbances in the solar system. Even minor shifts in asteroid belts or planetary positions are detectable with our current instruments, and the AI predicts anomalies that humans would struggle to notice without quantum-level computation. In short, quantum AI paints a picture of 3I/Atlas as more than a passing object. It's a cosmic anomaly. It's precise, unpredictable, and potentially unlike anything humanity has ever encountered. For scientists, it's a puzzle. For humanity, it's a wake-up call. 3I/Atlas reminds us that the universe contains objects that challenge not only our technology, but our understanding of the very laws of nature. In late 2023, astronomers noticed something unusual in the night sky. A fast-moving object, cataloged as 3I/Atlas, was hurtling through our solar system at an angle unlike any known comet or asteroid. Unlike most objects that orbit the Sun, 3I/Atlas came from deep interstellar space, entering our solar system on a path that suggested it had traveled for millions of years outside the gravitational influence of any star. Let's pause for a quick moment, drop a comment, and tell us, do you think this is just another strange rock? Or does quantum AI's analysis push you toward a more unusual explanation? And for the brave ones, what's your wildest theory so far? No judgment, unless your comment comes from 3I/ATAS itself. Telescopes on Earth could only capture blurry images, a small, faint dot against a backdrop of distant stars. It wasn't the detail that fascinated scientists. It was the geometry. By combining data from multiple observatories and even spacecraft, like ESA's Trace Gas Orbiter, astronomers could reconstruct its trajectory with unprecedented precision. It wasn't just fast, it was anomalously fast. So fast, in fact, that calculations suggested it had barely been slowed by the sun's gravity. Some scientists began to wonder, could this be artificial? Could it be a probe from another civilization, or something even more exotic? Here's where things get really interesting. Traditional computers struggled to model 3I/Atlas's trajectory accurately. Its path was influenced by tiny, seemingly random forces, micrometeor impacts, outgassing, solar radiation pressure, that are nearly impossible to simulate at scale. That's when researchers turned to quantum AI. Unlike conventional AI, quantum AI uses quantum processors to evaluate an astronomical number of possible interactions simultaneously. It can model the motion of 3I/ATAS at a level of precision no human could achieve. Within hours of analyzing the data, the quantum AI identified patterns no one had considered. First, it confirmed that 3I/Atlas was not behaving like a comet or asteroid. Its rotation, trajectory, and the way it interacted with solar radiation suggested something far more complex. Then came the terrifying prediction. If it followed its current trajectory, 3I/Atlas would exit our solar system, but not before passing close enough to influence planets with subtle gravitational effects. So, what makes 3I/Atlas so strange? Let's break it down. 1. Shape and mass distribution. Unlike normal celestial objects, 3I/Atlas appears elongated with irregular mass distribution. This means it doesn't spin or tumble like a rock, it rotates in ways that seem almost intentional. 2. Outgassing behavior. Most comets release gas as they approach the sun, forming a visible coma or tail. 3I/Atlas, however, showed inconsistent outgassing. Sometimes it spewed clouds of vapor, other times it remained perfectly inert. 3. Trajectory precision. The object's path seems too precise to be random. Even after accounting for gravitational forces, radiation pressure, and collisions with micrometeoroids, quantum AI predicts it would pass exactly where it did, almost as if it were guided. 4. Interstellar origin spectroscopic analysis of dust and gas revealed elements rarely found in our solar system, materials that form only in the cold interstellar medium, far beyond any star's influence. This wasn't a local object, it was truly alien. Each anomaly individually might be explainable, but combined, they paint a picture of an object that defies all conventional understanding. After weeks of computation, quantum AI delivered a chilling conclusion. 3I/Atlas is likely a naturally occurring object, but one that has been shaped or influenced by processes beyond human comprehension. In simpler terms, it's possible that natural cosmic events alone cannot account for its precise behavior. Some researchers speculate it could be a relic from another solar system, preserved in near-perfect interstellar ice. A cosmic probe, a passive object sent intentionally to study stars and planets. Something entirely new, a class of interstellar object that bends the rules of physics as we know them. The AI's analysis also revealed a subtle warning. The object's trajectory and rotation could generate gravitational or magnetic anomalies if it passes closer to planetary systems. While not immediately dangerous, the potential for subtle disruption exists, enough to make scientists uneasy. Let's be clear, 3I/Atlas is not likely to hit Earth. But the terrifying part isn't a collision, it's what it represents. 1. Interstellar intelligence. The behavior suggests intentionality. If it is a probe or artificial, then something or someone is observing our solar system, and it may have been doing so long before humanity existed. 2. Unpredictable physics. Even without intelligent design, 3I/Atlas exhibits properties that defy conventional physics. Its trajectory, rotation, and material composition suggest processes that our current models cannot explain. 3. Potential for future encounters. If objects like this are common, it means our solar system may regularly experience close encounters with high-velocity interstellar bodies. Some could carry unknown energy, radiation, or even microorganisms we can't predict. In short, 3I/Atlas is terrifying because it challenges our assumptions. It reminds us that the universe is far stranger and more complex than anything we've imagined. Despite the uncertainty, scientists are not panicking. Instead, they are acting like cosmic detectives. Observatories worldwide are tracking 3I/Atlas to refine its trajectory. Spectroscopy and radioscans aim to understand its composition in detail. Quantum AI simulations continue to model future paths and interactions, helping predict any gravitational effects it may cause on planets or asteroids. Some even propose sending a probe to intercept future interstellar objects. The goal? Understand their structure, composition, and origin, and perhaps learn if they carry signs of intelligence. One thing is clear: humanity's encounter with 3I/Atlas is a wake-up call. The universe is not a quiet, empty place. It's filled with objects that can challenge our science, our assumptions, and our imagination. Here's the takeaway: 3I/Atlas is a message in motion, whether literal or metaphorical. It tells us that our understanding of interstellar space is incomplete. Quantum AI is revealing patterns we can barely perceive with classical methods. The universe may be populated by objects that defy explanation. If 3I/Atlas is unusual, it may be just the first of many such visitors. Advanced technology could one day detect and interpret these anomalies in real time. We are entering an era where AI and quantum computation allow us to decode the cosmos in ways humans alone never could. It's a humbling reminder of how small we are in a vast, unknowable universe, and yet how powerful our tools have become in trying to understand it. 3I/Atlas is terrifying, not because it's coming to destroy us, but because it forces us to confront the unknown. A tiny speck of ice and rock from the depths of space is reshaping our understanding of physics, intelligence, and the limits of human knowledge. Quantum AI has peeled back one layer of the mystery, but the universe still holds countless others. Each interstellar visitor could carry secrets older than Earth itself, waiting for someone or something to decode them. As we watch the sky tonight, remember, the universe is alive with anomalies, and 3I/Atlas is just the beginning. If you want to stay on the cutting edge of interstellar discoveries and see what quantum AI predicts next, hit subscribe and turn on notifications. Because the cosmos is waking up, and humanity is only just beginning to see what's coming.